This is chapter 4.4, finding the distance or length of a segment between 2 points. You're being asked to find the distance between D, which is 1, 2, and E, which is 3, negative 2. Oh, let's try that one again in the wrong spot. 3, negative 2. We're going to connect those with a straight line. And we're going to go ahead initially and look at the distance using the Pythagorean theorem, because there's a connection between the Pythagorean theorem, a squared plus b squared equals c squared, and the distance formula. So there's a connection between the two of them. So let's go ahead. I'm going to draw the right triangle. I'm going to pause this while I do that, and then you can take a look at it. Okay, so you've got, there's your segment, the initial one, and then I use, let's go ahead and use a different color. I think that would have helped. You've got 4 right here, so that's 4. And then your other side is 2. There's your A, and this is your B. Your length of your segment is going to be your C. So let's just put C here. Let's go ahead and write that this is B equals. And let's go ahead and write that this is A equals. Now, it is A squared, so we're going to go A squared. We're going to put a square off of that, which is 4. And then B squared will be 16 because it's 4 by 4. So there's 1, 2, 3, 4 by 4. And that's going to be 16. And this is 4. And we know then that this particular one here, C, let's use a different color. C is going to be a square off of here. And it's going to be 20 squares because you're taking the 16 and the 4, and that's going to give you 20. So C squared, that means that C is going to equal the square root of 20. Now that can be simplified, and I'll talk about that later, but just to give you an idea of how the Pythagorean theorem works with the model. So now we're going to come over here and we're actually going to plug in the values. So we know that, let's choose a bright color, this point right here, D, is 1, 2. And this point here, E, is 3, negative 2. The formula says distance equals the square root of x sub 2. Now, it doesn't matter. It's just like slope. It doesn't matter what you choose as your x sub 2. I'm going to choose 3. So 3 minus 1. Okay, so 3 in parentheses minus 1 squared. And then plus, and then you go, if you start with the 3 and go to the minus 1, then you have to go negative 2 minus 2. And squared. So D equals the square root of 3 minus 1 is 2 squared, plus, let's go ahead and do negative 2 plus negative 2 squared. So D equals square root of 4 plus negative 2 and negative 2 is negative 4. Negative 4 times negative 4, or negative 4 squared, is 16. And so D equals the square root of 20. 4 plus 16 is 20. Now, whenever you have something like this, this is the exact answer, but it's not a simplified answer. You always look for perfect squares that will fit within this 20. So perfect squares are 1, that doesn't change anything, 4, 9, 16, well obviously 16 is too big, 9 times nothing gives you 20, but 4 times 5 gives you 20. So the square root of 4 times the square root of 5 is the same thing as the square root of 20. So you would actually write it as D equals square root of 4 is 2 times the square root of 5. That is your proper exact answer. Now, if you were going to approximate this, so D is approximately, then you're going to plug in just the square root of 20 into your calculator. Well, you know that the square root of 16 is 4, and you know that the square root of 25 is 5. It's almost right in the middle of that. And when you plug it into the calculator, you get 4.472135 and so on. We're going to round it to the nearest tenth, so 4.5. Again, it's approximately, it is not exact. This is an approximation. But many times you want to have an approximation, especially when you're measuring length, an approximation is more helpful. Now let's take a look at in the next little section how the Pythagorean theorem could become. So how did a squared plus b squared equals c squared become d equals the square root of x minus 1, x sub 2 minus x sub 1 squared plus the, in parentheses, y sub 2 minus y sub 1 squared. So how did it become? So we're going to take a look at that on the next slide. And so before we go over there, let's take a look at how you get a. Well, a is essentially your run. So you're looking at your run. Your y sub 2 minus y sub 1 is going to be your run here. Oh, excuse me, it's going to be, yeah, your run. Except that's x. Sorry, x sub 2 minus x sub 1 right here is going to be your run, which is going to be your 2. Your rise, again, this is all going back to slope, is going to be 4, which is actually going to be the difference. The rise are the y values, because it's not going up and down vertically, is going to be the difference between your y values. So that's where you get your a and your b. So x sub 2 minus x sub 1 is essentially your a values. Let's put it in the curler. And your y sub 2 minus y sub 1 is essentially your b value, your rise value. And then let's go ahead and take a look at how we went from a squared plus b squared equals c squared. So we have a squared plus b squared equals c squared, which can then be returned. I'm going to turn it around because we've got c squared equals a squared plus b squared. And then how do you go ahead and get this c by itself? Well, you take the square root of c squared, you take the square root of a squared plus b squared, square root of c squared is c, and now we have the square root of a squared plus b squared. Well, c is the hypotenuse, which if you remember from the previous slide, your c, your hypotenuse, is actually your distance of your line segment. So you can see it right here, the c, but then you can see that that value is the d value. Okay, then we talked about a. That's your run change. And c is just your distance, so d. And your run are your x values. So x sub 2 minus x sub 1, which should be familiar from slope, squared, plus, and then your b values are your up and down, your rise values, so y sub 2 minus y sub 1 squared, and there you have it. This is the Pythagorean theorem. And here's how it transforms into the distance formula. It is through this process that it goes from the Pythagorean theorem to the distance formula. Okay, now we're going to find the distance between j, negative 1, 7, and k, 5, negative 1. So the distance formula is d, because that's the hypotenuse, equals the square root of, and this is going to be your a values, your run values, x sub 2 minus x sub 1 squared, put together with your b values, which are your rise values, you'll see those in a minute, y sub 2 minus y sub 1 squared. So that's your distance formula. Now we're going to use the Pythagorean theorem over here, which is a squared plus b squared equals c squared. So I'm going to go ahead and plot negative 1, 7, and that's j. And then I'm going to plot 5, negative 1, and that's k. And then I'm going to connect them with as straight a line as possible. And this is going to be the hypotenuse of this particular triangle. So it's going to be a rise. The y value is going to be 1, 2, 3, 4, 5, 6, 7, 8. And then the run values are going to be 1, 2, 3, 4, 5, 6. And then off of this side that is 8, you would go a square, because you're going to square it. 1, 2, 3, 4, 5, 6, 7, 8. And you would make a square. And an 8 by 8 square is going to be 64. And then down here, I forgot to change the color. This is 1, 3, 4, 5, 6. And so this is going to be a 6 by 6 square. 2, 3, 4, 5, 6. Come over here. And 6 by 6 is going to be 36. Well, when you put together 64 and 36, you get 100. So our other square is going to be, and I can't fit it on here obviously, just do the best we can to make it look like a square. This is going to be 100 over here. Well, you know that this is A, your change in your x values. This is B, your change in your y values, and you know that from slope, change in x, change in y. Well, C is going to be your hypotenuse, and so you would say, okay, what times what give you 100, or what is the square root of 100? And that's going to be 10. So you know your answer is going to be 10. Square root of 64 is 8. Square root of 36 is 6. Okay, so we know our answer for C, the length of the line, or the distance between the 2 points, is going to be 10. Now let's actually do this using the distance formula. I'd like to have you try it on your own, see what you did, and then if you were able to do it correctly, then you can go ahead and just continue on. If you weren't able to do it correctly, go through the steps and see where you made a mistake. So try it on your own first. Now, as you can see, we already knew the answer was 10, so there wasn't going to be any need for an approximation. The exact answer is an integer value, has no fractions, no decimals. So my choice, and if you chose differently, that's okay as long as you end up with d equals 10, was to take 5 minus, these are our x values, 5 minus a negative 1, there you'll see it being squared. That's your change in your run values, your x values. And then your rise values, you can see here, which are your other side of your right triangle, because these are all right triangles, are going to be 8. So then you would have gone, okay, I went 5 minus negative 1, so then I have to go negative 1 minus 7, and square that. I'm going to use the additive inverse. 5 minus negative 1 is 5 plus 1 squared, which is 6 squared. Negative 1 minus 7 is negative 1 plus a negative 7 squared. Negative 1 and negative 7 is negative 8, squaring it. We've got 36 plus 64, and that equals 100, and the square root of 100 is 10. Okay, now I'd like you to do the Schoology distance formula assignment. I gave you a worksheet on this today, and it's page 194. It's essentially page 194, 4 through 6. I wrote the problems down for you, which I will do again, but I also gave you graphs so you could find the distance using the Pythagorean theorem on the graph. Again, these are the problems for 4, 5, and 6. The distance formula needs to be used, but if you've lost your worksheet, please note that just like in the previous notes, you're going to have to graph and show how you can find the distance of the segment, or you can find the distance between the 2 points using the Pythagorean theorem. So you're going to have to actually graph it and draw triangles just like I did in the previous notes. Otherwise, I provided it for you on your assignment. Well, good luck with this. Watch parts or all of it if you're still struggling.